Hey guys, in this video we are chopping up the fretboard, figuratively speaking, to really understand how the notes are laid out on the instrument. And in this video series, we're looking at how the guitar fretboard is really a combination of 6 geometric patterns, where in each video we're looking at one pattern at a time to then overlay our understanding of all these intervals in the end, like the different moves in chess, where we have a composite mental image of how all these patterns interact, not only in one key, but across all 12 keys symmetrically. Now, if that sounds sort of badass, it is, because music is amazingly organized and it follows some really simple geometric patterns that once you understand how they work, you can really navigate the fretboard with ease. And 2 intervals that we're going to focus on today are intervals 3 and flat 6, which show up in all sorts of music, all sorts of patterns like melodies and chords and progressions. So before we actually see how these patterns are laid out on the fretboard, let's look a little at the underlying theory behind these intervals. Using the key of C, for example, where C, the red square 1 here, is at the top, and then interval flat 3 in this key, E flat, is on the right, and interval 6, A, is on the left. These 2 intervals are on either side of the tonic. The flat 3 is sometimes called the minor third, so called because it's not part of the major scale. But the interval of a sixth, also called the major sixth, is in the key's major scale, hence the name major sixth. The major sixth is also sometimes called the submediant because it's midway between the 1, the tonic, and the 4, the subdominant. So it's the mediant, or in the middle of, 1 and the subdominant, hence submediant. Both of these intervals, the minor third and the major sixth, are somewhere between consonant and dissonant in a given key, and there's a reason for that. Because not only are they evenly spaced around the tonic, 1, they're also both evenly spaced around the sharp 4/flat 5, or the tritone of a key. And earlier in the series, we saw how the tritone is the polar opposite of the tonic in a key. And so it sounds very dissonant with the tonic, interval 1. And so since the minor third and major sixth have this dual affinity between both the tonic and the tritone, since they're evenly spaced from both, there's a kind of audible tension between all of these intervals in a key. The flat third and sixth also form a pair of tritones themselves, giving them a kind of haunting sound because they sound good with the tonic, but dissonant with themselves. The tonic 1, flat 3, 6, or mediant, and sharp 4/flat 5, the tritone, form a square of evenly spaced notes, that is, 2 pairs of intersecting tritones. And since the flat 3 and 6th form a pair of tritones in their own right, they have kind of a haunting sound in any key. Because they both sound nice with the tonic, but they have their own tensions going on here. Now in a circular formation, where the chromatic scale forms a ring, it's easy to see how these intervals are laid out to form a perfect square in 2 intersecting tritones. But they also form a very interesting pattern on the guitar fretboard where you can play the notes and hear how they really sound. So let's start in the key of C as an example, where we fade all the other notes and focus just on intervals 1, flat 3, and 6. And when we condense the fretboard so that all of the frets are evenly spaced, you can see how the fretboard is like a chessboard where these notes are laid out from one string to the next. It's beautiful, right? These intervals sound so haunting, so nice. So starting on the 6th, major 6th, so on the 6th string, 5th fret, A. And in the key of G, where we switch to the red-orange circle as G, 1, and then B flat is the flat third, and E, the yellow square, is the 6th. Let's play that pattern in the key of G. And then when we move to the key of D, the same interval pattern applies. D is the orange square, F is the purple-red circle, flat third, and then B is the yellow-green circle, or the major 6th. So starting on the F note, which is the minor third, 6th string, 1st fret. And then we can play the same pattern in the key of A. And since all 12 keys are consistent and symmetrical, they are therefore predictable as well. So you could play these same patterns, these same geometric sequences in all 12 keys, and they'll always sound a bit dramatic and even tense or melancholy because of those dissonant connections between the different intervals, between the minor third and the major sixth being tritones, and because of those two intervals dual affinity with the tonic interval 1's tritone, the sharp 4/flat 5 in a given key. And because of these two intersecting tritones, they form a perfect square. And you'll notice if you look closely that because of this perfect square between these intervals, there are really only three squares of minor thirds and major sixths in all 12 keys. 12 divided by 4 is 3. So once you get a feel for how these intervals work in one key, you've already started to get a feel for how they work in a handful of other keys because they all follow the same geometric patterns. It is totally beautiful. So in the next video, we're going to focus on another pair of intervals that are geometric as well, which show up in a lot of music, and they are the 2 and flat 7. So definitely check it out, and I will see you there.